A mango is launched at 62.1 meters per second at an angle of 72 degrees above the horizontal onto the top of a cliff. So we are shooting from the ground onto this cliff. The cliff is 85 meters tall. This happens all the time, you know, in physics land, right? Okay, and then that's 72 degrees. And this is 62.1 meters per second. So this thing's going to go and hit there, right? So the first thing I'm going to do is I'm going to find the components of this. Okay. So I'm going to check, am I actually in degrees? Indeed I am. Okay. So I'm going to go 62.1 cos 72. All right. That's 19.190. If I round it to 5 sig figs, and that's meters per second in the x direction. And then I'm going to do the sine of this, right? So 62.1 sine of 72. And that is 59.061. I'm just rounding, again, I'm just rounding this to 5 sig figs. If I round it to 5 sig figs, I really am good. Really 4 is probably enough, but you just don't know, you know? All right, I feel like we know for this problem, we know this. We know this. We always know this and this, right? And then we know this. And then because of this problem, we know that, right? Okay. Time with horizontal distance, okay. So, all right, let's do this. All right, so this is 0 and this is negative 9.81. We always know that, right? This is 19.190. And that's because, of course, you can't change the velocity. If the acceleration is 0, right, it's not speeding up, it's not slowing down horizontally, right? Vertically, though, it does, right? So 59.061. And then this displacement is, it's onto the top, so it's up 85. Right, so it's up, right? Okay, all right. I think, you know, you just kind of always do these the same way. So to solve for t right away would be quadratic. Okay, so I'm going to solve for the final velocity. So in the vertical direction, right, let's use v squared as u squared plus 2as. Right, so that's going to be the absolute value of v is the square root of let's see, 59.061 squared plus 2 times negative 9.81 times positive 85. All right, let's see, let's find this. I got it, all right. So square root of, I gotta use parentheses here, that guy squared, right, plus, and notice that this term here, since that's positive, the g is negative, and so this term here is going to take away from that term, okay? So 2 times negative 9.81 times 85, and then I got to end my parentheses here. All right. Ooh, this is an awesome number. This ends up being the absolute value of v is 42.666. Oh wow, this is a crazy number. Okay, but it's 667 would be with, if I rounded it, right, meters per second, right? So we're going to choose. We're going to say that v is negative 42.667, right? And notice that it's a smaller number than this, right? And that's because it's way up here, right? Okay. We're choosing negative because it's going down, right? When it hits the ground, right? That's why we choose the negative. Choose the negative. So negative 42. All right. And now we can find the time. The time is going to be v equals u plus at. Whoa, it's slowing down on me. Okay. So the final velocity is the initial velocity, right? 59.061 plus negative 9.81 times, oops, sorry. We know the final velocity. So negative 42.667 is equal to 59.061 plus negative 9.81 times t. And now we can solve for t. Okay, so let's see. All right, let's see, divided by 9.81, 10.3697. Right, so I'm going to put that in there. Is that right? It would be 37. Actually, let's see, 10, 369. It would be 3698 if we rounded it, right? So 10.3698. Getting a little out of hand. That's like 6 sig figs, right? And then that time goes across, right? It's a 10.3698. I guess we could say 360 or something like that. Anyway, okay. So that is our time. And then in the vertical or the horizontal direction, we could find S, right? S is UT, right? And that's going to be 19.19 times 10.3698. Okay, so let's see. Times, let's see. 198.99, so 199 meters. Ta-da. So that is how far it goes, right? How much time is it in the air? It's in the air for 10.4 seconds, right? The other thing it asks, it will tend to ask, is like what's its speed of impact? So we can do that. Let's do that. The speed of impact is going to be the hypotenuse of this guy, right? So it's going to be the square root of 19.19 squared plus 42.667 squared. All right, here we go. Square root of that guy squared plus this guy squared. And that's 46.8 meters per second. So if it asks you for the speed, just look at that final velocity there, right? I'm getting 46.8 meters per second. This problem doesn't ask for that, but some of them do, so just be careful. All right.